Hello, everyone, and welcome back to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I am your host, Tina, and today we're going to be talking about the incredible PCGX plugin. And there's a lot to get into in that. I'm personally very excited to dig into today's topic, but there's a couple news beats that I want to go over first before we dig in. First and foremost, I want to talk about Unreal Fest, specifically Unreal Fest Orlando. It's coming up very, very soon. It's going to be taking place from June 2nd to June 5th, and registration is currently open. So if you're interested in going and hanging out and checking it out and seeing what all is to offer, you can do so still. Tickets are still available. A couple of the things that I specifically want to call out is, of course, so State of Unreal, typically, which is the time where we give our biggest announcements, the biggest and greatest. We give a good look at what's coming up in the future. That usually happens around GDC, but this year it's moving to Unreal Fest Orlando. So if you want to be there for the legendary State of Unreal, you can do so by coming to Orlando this year. We've also got a couple of other really cool things that are available in the agenda, which you can find this available online too. You can go through, see what all talks are currently prepped and planned. But we've got a couple of really cool ones, like a peek at some of the future features that are coming to Unreal Engine, as well as the latest updates that we've done with mobile development in Unreal Engine, a lot of things around MetaHuman Animator, so on and so forth. Lots and lots of really cool topics. So check that out. If it seems like something you're interested in potentially going to, register. Do it. Do it now while you still can. All right, anyway. So that's everything with Unreal Fest. And then the second thing I wanted to talk about is we have a survey currently out and about that is for Epic Online Services. So, very specifically, we want to make sure that the Epic Online Services are tailored towards you all, the people that are using it. Feedback of the Unreal Engine developer community is crucial for making sure that these tools continue to develop in a way that is useful for you. So whether you're actively using EOS, have tried it in the past, or have never even looked at it at all, it doesn't matter. We want to hear from you. So if you have the time, this short survey helps us understand what you need, what's working, and what we can do better. It usually only takes about 10 minutes, sometimes even less. So if you have the time for it, please check that out and give that a gander. All right. Well, that's everything for the news this week. Let's go ahead and get into the topic for today. I'm going to go in and have our incredible guests, the minds behind the PCGX plugins, introduce themselves to us first. So, Ed, let's start with you. Why don't you tell us a little bit about yourself?
Hi, I'm Ed. I'm not the mind behind PCGX. He's going to be introducing himself next. I am the director of a company called Jean Paul Software. I say director in quotes because there's only one employee, and it's me. If you're wondering what the joke is, Jean Paul Sartre, great philosopher. That's the joke. It's a really good joke, and people often say that if you have to explain jokes, they're not good jokes, and those people are wrong. So I am making a game called The Last Gig, which is about getting across London to put on a rock concert in the face of an AI apocalypse. And I'm using PCGX to fill in the blanks of the stuff that I can't spend money on, essentially. So yeah, that's me.
Yeah, what I mean, there's no better proof of concept than actually releasing a project with it, right? So there you go. Then
Well, if
next
it gets
up,
released, yeah.
then next up, Tim, why don't you tell us a little bit about yourself as well?
Hey, I'm Tim. I made PCGX basically. I've been game dev for quite a while now, and I'm absolutely exploiting Ed as being my main user for a long time now. So it felt just natural to have him talk in my place because I don't do those things much. But yeah, that's pretty much it. Like during the day, I'm mostly focusing on UI, UX stuff, and during the night, I'm doing more tech art tools, um, just having fun in my own ways.
Very awesome. Fantastic. Well, for those who might not be familiar with what PCGX is, can either of you give us just a quick summary of what is this plugin and what are we going to be getting into today?
I mean, I can if you like, or Tim can. I mean, up to you. Thing is, if I say it wrong, doing it in front of the creator, so it's probably okay. Shall we go to the screen share and then we can just like start off that way?
Yeah, absolutely.
Okay. So this is well, it's London. Giddy London. So this game that I'm writing is I wanted it set in London. I'm a big fan of things that like media in general that is set in the present, because there's lots of things that are set in the distant past, lots of things that are set in the distant future. But it's important to have stuff that's set today that isn't just about shooting people in the face in dusty countries across the sea. So basically, there's a near future AI apocalypse. When it's set in London, because I live in London, and so that's a bit easier for me to sort of get reference photos for than somewhere else. And basically, that means building London, and you can't just build London, right? That's mad. So you have to kind of get the computer to do it for you. Well, I mean, there's other options. I mean, you could try importing it from Google Maps, for example. There's some plugins for Blender that let you do that. And I tried that to start with, and I got a very, very large file, and it was just impossible to do anything with. I had no control over it. So it's like, well, can I come up with an algorithm to build a city? Now, the problem is, if you look at the city sample, that's all on a grid. In fact, like a lot of American cities are on a grid, which is why when you play games, typically they're in these grid-based places. If we look at what London's like, it looks like this. It's a mess because we've had plagues, rats, fires, wars, Romans, like all sorts. That's how London ended up being like it was. And if you compare that with, say, Oklahoma City, wait, is that Oklahoma City or is that Oklahoma City? I mean, I can't tell the difference. That is a joke. I'm sorry if you're from Oklahoma City. I'm not saying that you look like Microsoft Excel. The point is, if it's on a grid, it's a lot easier to just spread things out because grids are very regular. You can have control over where you're placing things. If you're doing something like London, you've got a much harder thing to manage. And like I started just trying to attempt this problem. I in previous career I was doing a lot of data visualization. So I started with D3 and I got something that looked relatively convincing. And I started taking this into Unreal and I was trying to do it with the there's a geometry algorithms package within Unreal C++, and I started trying to do it with that, and I kind of failed. And then I typed the right thing into Google one day, and I found PCGX, and it just did everything. Not quite everything. I still had to do some work. It's not that amazing. You still have to actually do something with it. But basically, what it does compared to regular PCG is it gives you a way to create structures essentially. So with regular PCG, you're more interested in sampling things and play that are already there. So you have say some rocks that an artist places, and then you use PCG to cover them with moss and other things like that. The tools are getting better all the time. I think the way that they've structured it is definitely the right decision. But if you're like me and you don't have an artist, or if you want to get an artist to do something, they're going to have to do something like good, as opposed to putting lampposts everywhere. Then you need to automate as much of this as possible. And that is essentially what PCGX helps you do. So if we go back to this, we've got this notion of roads, and we've got this notion of cells, and we've got each one of the I'm sorry, I'm pointing at the screen, but I realize you can't see where I'm pointing. If you look at the we zoom in on one of the crossings, this is like the intersection of a bunch of roads, and then between the roads we've got these areas which are enclosed, and those are essentially cells. And you can use PCGX to create these kind of structures, or like essentially a graph, but a graph in the computer science term. So nodes and vertices and orderings on those. And so I did a load of work with this and yeah, wound up with this. So other things that we can show off is there is this zone graph interoperability. If you are familiar with maths, that's all that is what is used in the city sample for the pedestrians and the cars. There was me and I can't remember the name of the guy on the another guy on PCGX Discord were just talking about this, and then Tim just went off and did it because he does that sort of things. And so, like, suddenly I've got traffic, and that was really nice. So yeah, let's I'll tell you what, let's go back inside. We'll show you off some other bits of the game, and then we will go to the room that I have created that is really going to sort of emphasize what I'm talking about. If we get some time later on, maybe we'll talk about some other procedural things that you can do in Unreal. We might not have time for that. We might. Let's see how we do. So yeah, start the game in this rubbish flat. We've got a very interesting carpet. This was generated procedurally, not in Unreal, but in JavaScript. But if you're thinking about procedural generation, it's not just about putting stuff in the world. There's lots and lots of things you can do. You can create textures, you can create sounds, you can create sort of behaviors of things. Like it's all kind of like approach to building things. PCG is a very important part of that in Unreal, but it's worth bearing in mind. There's all sorts of other things you can do. So just look into it as much as possible because this is really interesting stuff. One really fun thing is, I suppose we can talk about procedural animation. So this is a working drum kit that we have here. So if we want to, sorry, that's the wrong button. No, that's the cymbal. That's the one. They've got the hi-hat over here. But like this is all being animated with physics, and that is a form of procedural animation, for example. So if we come out of that. So we've got over here. So I am in the process of building this demo. We've got another procedural carpet there. We won't talk about the cricket bat just yet, but basically I've got to make a demo because I want to get some funding, and so I need some stuff to show off. Now, if you go to the Stealth Gardens, that's where the actual kind of like gamey bit is. But like, I also need to get some people just to test the sort of traversal mechanics that are built into this high-tech cricket bat. So we are going to go down here. We're going to have fun. We're going to kick the door open, and we are going to go to the gym. Now, unfortunately, I haven't quite worked out how to open that door and then actually transition to the level in the editor. So we're not going to do that. We're just going to open it like this. It would have been a really good transition if that had happened, but unfortunately, just imagine that has.
Yeah,
while it's loading, just envisage like how slick that would be in particular. Like, wow, yeah, that's a really good transition. I'm going to use that in my presentations.
Ed, that was incredible.
Yeah, it was, wasn't it? Yeah, thanks. Yeah, it took a lot of work to work out how to do that. So we're in this kind of level, and there's nothing here. So this is sort of emphasizing the point about. I mean, there is something here. We'll get into that in a bit. But it's just to emphasize that we're not talking when you're using PCGX, you can use it to augment stuff that's in the world. But for me personally, the thing that it brings is the ability to create a structure and then use the rest of the PCG tools to build on top of that structure, as opposed to having an artist place the structure or to have to place the structure yourself through some other way. So if we go over here, what we are going to do is we are in the middle of nothing, and we are going to turn this floor, which is your standard Unreal 1 meter cube, we are going to turn that into a world-class art center. So let that sink in. The world-class art center is not actually the Barbican in London. It's the Ultra Barbican because we're going to go significantly further. But this was where the London Games Fest was a few weeks back, and also I kind of wanted it in the game. So I wanted something that I could test the traversal with. I wanted to build this place anyway, and I needed something for the demo. So I thought, well, let's just do all of that at once because, again, one bloke doing everything, just got to cram as much stuff into jobs as you can possibly get out of them. So we will wait for the lift to go up. Doors open. Technically, those doors are procedurally animated as well, but we don't need to get into that now. Got another exciting carpet, again, procedural. We have what I like to think of as environmental storytelling. There we go. There's some environmental storytelling. Got an ashtray anyway over there. But as you can see, there's nothing. But there's the fire safety notice, and the assembly point is outside Pret a Manger. I don't know if that joke works in America. We have quite a lot of branches of this sandwich shop called Pret a Manger in London. It'll be really funny if you're from London and you're playing this game. If you're not, then you won't notice it, so it's fine. But anyway, so let's just get into it, basically. So again, we've got nothing. All we've got is like the lift, and we have a cube. And what we are going to build, just to reiterate, is if we zoom in here, we have London's Barbican Centre. So we're not actually going to build the art centre bit because that is too kind of like architecturally interesting. It is something, if I'd had more time for the presentation, I could have looked at. But we're not going to. But like the main thing is we've got these towers, they're like a particular type of thing. We've got the kind of like the residential blocks surrounding these gardens. We're not going to bother with the tennis court. There's also the lake. So this is the main art centre over here. This is really nice to sit in. There's a library in there and stuff. It's a really good library. This bit at the top, that is the Arboretum. And I would say that is one of London's hidden gems. So if you find yourself in London, go to the Barbican on a day that the Arboretum is open, just check it out. Check out the library as well. It's really cool. But we've got this kind of structure. So I had to think about ways that we could approach building that. So we are going to jump back into the editor and we're going to start where we start. So the first thing we need to do is actually get some variables from the world. So we need to work out how big that cube is. So when I talk about the cube, I'm talking about the thing that is marked floor here. This is a cube. It doesn't look like a cube because it's very wide, but that's because it's scaled. Topologically, it's a cube, and it's more interesting, narratively if it's a cube. So we are going to work out how big it is, right? And then we're going to save these variables as attributes. How can we get a sense of like how much PCG knowledge we're going to need to have as a prerequisite for this from the people in the chat? If things aren't clear or if we're going too fast, I mean, because I imagine some of you haven't used PCG before, so we might be a little bit advanced for that, but hopefully you'll pick stuff up as we go along. I mean, does anybody have any questions on that? Is that I don't actually use Twitch myself, which is probably bad, but like, is there a way of getting a poll or a sense of like how much knowledge people have got on this kind of stuff?
Yeah, well, I mean, just let us know, chat, maybe on like a scale of 1 to 5. 5 being you are an absolute master of PCG, you know everything to know about it. 1 being you're fairly new to it or completely new to it. On that scale, go ahead and put in chat now where you feel you fall on the list of the category of how well you know the tools here. Looks like we do actually have quite a few beginners, which is awesome. Thank you for being here. Glad to know that you're interested in the tools. Let's see. Okay, so it looks like on average it's falling between 2 to 3. We've got a few ones in there, a few 4s and 5s, which is awesome. So we've got quite the range.
Okay, well, in that case, let's do a bit of the basics first because that will just make things easier. I did write start writing here we go, johnpaulsoftware.com. I did start, if you go to my website, again, John Paul Software, apart from the plug for this talk, there is this blog post here. This goes through some of the very basic stuff that's on there. This is another really good joke. If you know who Leonard Cohen is, you're going to think that's amazing. If you don't, never mind. Broadly speaking, you in PCG, what are we doing? We are trying to find out the locations of things and then put them somewhere, or like take a bunch of what are called points, put them in the world, and then do something with those points. So if we look at this node here, what this does is it gets the data about an actor. So here I'm getting an actor which has been tagged with the floor. That is this one. If I go to floor and we search tags, we get the floor. So it's just getting the information that is about that. And what it gives us is the position in the world. So this is one of the properties there. So we've got position, gives us the scale. So basically the transform. There's a couple of other things it gives us. One is the bounds min and the bounds max. That's basically if you think of it like a bounding box that it is occupying, a sort of like axis aligned bounding box. So like if it was this book, for example, that would be the bounds. But if I add, well, actually, no, that's a really bad example. But it's basically a rectangle, a cuboid that surrounds the object. There's some other properties. It's got a color. That's optional. There is this thing called density, which is a kind of like all-purpose number that you can use. It's not actually. It's usually between 0 and 1. It can go to. You can have it as high as you like. But typically it only really makes sense between 0 and 1. And then there's this other thing called steepness, which is kind of like the fall off on a gradient. So like Tim can correct me if I'm wrong, but like if you think about like going into Photoshop or whatever, you've got the gradient tool and you put black at the top and white at the bottom. The best way to think about steepness is changing where the stop in the middle goes, because that's how much it ramps up, and that's used in a few places. I don't typically use it because I'm just really interested in the center of the points, but it's there if you want to do it. Then we have this other thing, which is the seed. So if you're not familiar with random number generators, that's going to seem weird, but computers can't generate random numbers, is the main thing. What they can generate is pseudo-random numbers, where you've got this basically fat mathematical expression, and you put a number in there, and it spits out a number that looks totally unrelated. And that is a pseudo-random number generator. If you put the same seed in, you'll get the same result out. And that's got some quite useful properties, particularly for doing stuff with procedural generation, because what we want is if you created a world, for the most part, if you created a world and you're using PCG to put stuff in it, it doesn't have to be trees. Frequently it is trees. We're trying to get away from that. I know there's some people at Epic very keen to highlight that you don't have to do it with trees. But let's just say, for the sake of argument now, that it is trees. If you've got that outside your village, you want the trees in the same place every time someone opens the level, because if the trees move around, it's going to get very, very confusing. And so we use the seed for that. Normally, you don't have to think about it; it just gets processed in the background. But that is the point. That is a point. That is the main thing that you're processing with the PCG framework. So following on from that, we've got these other things which are called attributes. So here we've got get attribute from point index. And if we look in the view down here, we can see what that attribute is. Now, an attribute is kind of like a variable. Well, in fact, it is a variable in essence. And they can be connected to points, they can be connected to splines, they can be connected to other data types that are within the PCG framework, but they're not actually on the point. So it's separate, it's metadata. And that means you can do some pretty clever things. It means you can store those things separately, they get processed separately. The points, in terms of just technically helps you process the thing that you want to process. And I did have a really good explanation for this, but it's not coming to mind. Anyway, basically just think of them variables. Those are the two main things that you're going to use in this. So if we look at this node here, so we're taking this attribute here, which we established was the extent of the floor. Just going back to another quick beginner thing, if you've got the bounds of the object, like again, we can think of the bounds as like the cuboid that it takes up. The extent is how far it's going out in each direction from the center. And sometimes you want that, and sometimes you want the bounds, sometimes you want something else. But that is something that you can access by using one of these operators here. So when you want to get actually, no, let me rewind a bit. When we look at a point, so again, I hope people can actually see this in the chat. All of these things here are prefixed with a $sign, and that means that those are properties of the point itself. So position, rotation, scale, bounds, etc., color, etc. But these aren't, if you look at the definition of the point in C++, it doesn't actually have a position property. What it's got is a transform property. So there is this notion of accessors to properties and accessors to types. And so when you see something with a dollar, if you see something with a dollar, just assume it's something on the point itself. It might be on the transform, it might be elsewhere, but we can do other things. So for example, if we wanted to get the rotation of this, let's just do this quickly. Here we type in the input source that we want from what's being processed. In this case, it's a point. This dollar extends. But I can do things like I can do rotation.forward, and it will get the forward vector of whatever the rotation is. So there is some kind of sort of, syntactic magic going on behind bounds. You can see these extractors here, which is basically what's doing those. These are just different ways to access the data that is already on the point. Anyway, is everyone clear enough, or at least confused enough to shut up for now? Just another quick, if there's any questions about anything particular, maybe hold them till the end. We can go through stuff, or Tim can take over. Tim, have I said anything totally stupid yet?
Nope, all good. One thing to keep in mind is that density and steepness are used in a lot of nodes and in very low-level code. So steepness can surprise you when you start doing differences, union, and stuff like that, because by default, I think it's 0.5, but usually you want it at 1 to do most of the things that you actually want to do with difference and unions. So just something to keep in mind when you don't get the result you're looking for. Look at steepness, look at density. Those two probably needs to be at 1, and you're going to get what you're looking for. Because
Yeah.
it's just, yeah.
Yeah, I'd second that. I've run into that in the past. I mean, fortunately here it is 1, so otherwise I probably would have got very confused and not actually finished this. So we have attributes. So again, when we've got this attribute, we've got this. You can do the same operations on attributes as you do on properties that are on points. So here we're multiplying this by 2. Now this is our first PCGX node, and it just happens to be the one that I wrote, which is great. It's not the complex stuff that Tim did. Basically, you're going to be if you're doing stuff with PCG, you might be typing create attribute and not a lot, because if you want to create a variable to use, you go create attribute, and you go over here, and then you select what type of thing you want it to be. So let's say I want it to be a vector, and then I want the up vector, so I make that 1. And basically, I got sick of doing this because I was doing it a lot, particularly that city. The city is quite complicated, by the way. I don't think it's going to happen in 5 minutes. So I got a bit sick of doing this, and I just like, so why can't I just type 0 to get 0, and why can't I just type 2 to get 2, and why can't I just type up to get an up vector? Because 90% of the time, any sort of creative development, at least that I've experienced, there's only like 5 numbers that you need, and those are 0, 1, half, 2. Sometimes pi, but you don't really need that in Unreal because everything's in degrees anyway. But if we look at the full list of constants, we've got like a whole bunch of them here. So that is a kind of really, really great workflow example. It's not as exciting as the stuff that Tim has done because Tim's done all the hard stuff, but like I did that and it's really good. So,
It is. Actually, no, but it actually is. Like, it's super low key, but it does save a lot of time in the end. So
yeah.
I respect those a lot.
Well, thanks for accepting the pull request. Anyway, so we can do operations with attribute sets, just like we can with points. So again, when we're like looking at this stuff over here, this isn't connected to a point. This is just an attribute set on its own. We're just doing maths on some numbers. But then later, we're going to connect these back to the points, and then we can use them again. So just bear in mind, there is this notion of an attribute. It is not connected to a point, but each point has got this metadata entry field, which is hidden, that allows the attributes to be connected to the points so that you can basically put arbitrary data on a strongly typed object, which is kind of really cool. And like one of the things that just amazes me about PCG, because I hate getting involved with type systems in C++. Anyway, so that's hopefully the basics. If you're still confused, I'm sorry, but there are plenty of good tutorials on this, and we want to show off the plugins. So first thing we're going to do is we're going to try, again, go back to this. We are trying to build. Just quickly refresh what we were doing before we did the digression. So we have the Ultra Barbican. We are trying to build the Ultra Barbican. The Ultra Barbican, no, that's Gitkraken. No, the Ultra Barbican looks like no, it doesn't look like that. It looks like this. That's the right thing. Right. So it's pretty blocky, right? So we've got some squares over here. We've got a lake. So we can probably just do this with a bunch of different rectangles, right? I know I said like I don't want to use wet rectangles, and then I made fun of Oklahoma City, but in this case, this is one of the few places in London that's square, and it's really handy because it makes it a lot easier for us. So that is what we're going to do. So we want to create something that, if I can remember what I'm clicking on, we want to create something that does that. So let's go. So I had to think about this, and the thing that I thought was best would be to lay out a bunch of squares in a circle, but like only like 5 or 6. So if we zoom out a bit, so we've got like 5. So we've got 5 points that are just aligned to the world. And then what we can do is that what we can randomly, if I remember, where are we? If we do this, yes, we want to debug that. Sorry about this. I should have done this earlier. Did that work? Did it? No, it didn't. Okay. Sorry. Bear with me 1 minute. So basically, well, let me just explain what we're doing. So like PCGX has a function called create shapes. With it, you can create a circle. So you create a circle of points.
That's the only shape.
Sorry?
That's the only shape right now.
That is the only shape. But it's a really good shape because you can create lots of them. Or, any polygon you want. As long as it's a regular polygon, you can create with a circle. So with this circle, we just say that we're going to have 5 points. We turn that 6, and I've turned the debug off. So no, don't click on help. Let's just put that back in. Then we've got 6. Got 6 points in a circle, but we're going to stick with 5 for now because that's what I started with. So take that, turn that back to solution 5. And then we're going to use these things here, which are attribute noise. I think I found the right thing to debug. Try that. Nope. Hang on. I think it's probably in the wrong place. Let me try doing that. There we go. Right, okay. So they're actually under the floor. That's why we're having that issue. For each one of those points, we're just going to sort of randomly expand it out. That's what the attribute noise does. So we're going to set the scale on the y-axis randomly between 150 and 250, and similar on the x-axis. And then we're also just going to randomly flip some of them 90 degrees. So if we do that as well, no, wait, that's just the ones that were flipped. We don't want that. We want this one. Go back here. So we've kind of created a pretty random layout. Now, if I go back to this random choice node, for example, you see we've got this seed up here. So what I can do is I can change the seed, and if we go back, different ones will get rotated around. Or I can, let me just undo that. Actually, I've got the nodes saved. We can do the same on the attribute noise node for this. So if we just change this, then we get some turned around like that. If we change it differently, I'm having to do this on one screen, so it's a bit hard to go back and forth. But you see, like, they're scaling different, right? So basically, we can play around with that until we get some values that we like, which is what I did. And so let's just bring that back in. Let's get rid of these ones. So these are the good values that I like. And then what we're going to do is we are going to turn the shapes that we've got. We're going to take them, we're going to turn them into a path. Now, what is a path? A path is like an ordered sequence of points. That is something that exists kind of in regular PCG. It's normally done through a spline. But in PCGX, you don't need to bother with the spline bit. I mean, you can if you want, but you don't need the spline. You can just create an ordered sequence of points. So let me get rid of that debug. So this is a subgraph that I've made, which basically gets the, we had the rectangle. It gets the points around the rectangle in an order that turn it into a rectangle when it's a path. And then what we're going to do is we add a tag to it. Oh, yeah, there's something else I should mention. Whilst we've been doing that, I've created another square to go around because the way they were laid out, we need something to kind of cut through those to create a center, essentially, to give us some sort of inside and outside. So if we enable this, you'll see what we've got. So here we go. So those things that were previously square, they are now paths. If I go back and I turn the, no, where's the thing? No, it's not there. Anyway, so this is the kind of killer app, I think, or well, killer function or node or whatever of PCGX, which is this path to clusters thing. Clusters are, again, it's a undirected graph. It's a direct. Well, is it undirected or directed? It can be. It's an undirected graph.
Can be both.
Can be both. But again, you've got if you remember your first year computer science, you have this notion of points and edges connecting them, and that is a graph. And what PCGX does is let you create these, and this is your structure. This is the structure that I was talking about. With this, you can create surfaces, you can create splines, you can create regions that you fill with things. You can interrogate what's in them, you can interrogate whether things are in them or outside them or on them, all sorts of things. You can combine them, you can move them around. It's really, really cool stuff. And you can also filter what's in there. Let's carry on. So again, this is now we've got something that looks a bit like the layout of, or the floor plan of a complex, right? So we're already like leagues ahead. And again, all we've been using so far is this cube. So there's no artist place stuff. I mean, I did place the cube. I wouldn't necessarily count myself as an artist, but we did place the cube. But just that, from that one thing, we've created a lot of structure, and that is, for me, the main thing that you get from PCGX as a great addition to all the brilliant stuff that's already in the regular PCG framework. And yeah, so there we go. So let's, how are we doing for time? We probably need to start like accelerating a bit. So Let us disable that. So we're going to do some more processing here. So we're going to get rid of like anything tiny, because tiny things are a bit rubbish. If you're laying out some sort of like Tina's laughing. I'm not quite sure why. It's not a euphemism. It can be if you like, but I don't. It wasn't intended as one. Um, Basically, if you're laying out some sort of like big complex like this, you don't want lots of tiny little walls or like very thin buildings or anything like that. So we want to get rid of anything that's unnecessarily small. So we're just going to crudely going to sort the like. There's this path property nodes which lets you work out different properties of the path. Again, this is really, really useful. One of the things it lets you work out the area of the path that you've just created. So it's great. We can just sort of do that. We can do a bit of attribute fiddling and get sort them by their area and then get rid of the smallest ones and then do this match and set to keep the ones that are there. Then again, we're going to add another square over the top because when I was doing this, it's like, well, we need something that's kind of inside. If we just go to, let's just do debug agents. Actually, no, let's do debug paths. So with all that done, we've basically we've taken our the initial rectangles that we had. We've added a couple of squares. Now what we want to do is we want to find all the points where they intersect, and we want to find the regions. And this is the next really, really amazing node that just made everything so much easier, which is this find all cells. And what that does is it takes the paths that you've got before and it breaks them up into regions. So if we look at this, it looks pretty much like it is before, but we've kind of marked out where things are crossing. And now each one of these things, these regions, is a path of it by itself. So it should be a path with 4 points, or this one is going to have more points. But that's what the find all cells does. And you can use this to do all sorts of things. If you're doing city blocks or whatever, you can do this. It doesn't have to be on this kind of like linear grid. You can do this. You'll find regions, and then you can do really great things with the regions using the rest of Unreal, using the rest of PCGX, and so on and so on. Now, to illustrate that, if we go back to our graph here, there is a bug. Hopefully, we don't care. You see, it's created a load of different data sets out of here. So we've got now 26 of them over here. And we went in with, oh, there's 19 there. Hang on, I've missed a bit. Oh, no, wait. So we did that earlier. Wait, where are we? Okay. So, yeah, so we've gone from 5. When coming out of find all cells, goes up to 19. And then we do a bit more work with the other stuff, and we find all the cells again. So I've got that part of it, and we've got even more stuff. So just quickly, let's talk about the rest of it. So basically, there's this inner square, which is this one here. I'm going to say that anything in there is like the lake or it's grass. Anything outside that or that is touching that is going to be one of the buildings. So if we go back to what we're trying to imitate over here, which is this, you've got the lake here. This is what I'm saying that inner square is. And these things that are touching it, those are going to be the building blocks. So where are we? Okay. So we do some stuff. I think we probably spent enough time on this. So we have our macro layout. And we found the regions that are touching the inner quad. There's this thing you can do in PCGX where you sample points. So if you've got 2 points on a path, if you want to work out whether something's touching something else, you can sample the points on the other path, and it will tell you whether they're close enough. So we can use that to work out what's touching and what isn't. Then we go do some other stuff. And here I am splitting things up into different types of region, essentially. So like the regions I want: concrete, grass, lake, building, and kind of void. Because like that's the stuff that's in the Barbican. So we need different regions that do those different things. Okay. So we do all of that. we do a bit of stuff to sort them around the edge. Then we alternate between block and not block. And once we've done all of that, we get something out. So if we go here and we do debug paths, this is a variant on the debug paths node. That's what we've got. But that's not really very interesting. That's not really showing you what's different. But like I was saying, we sort of like split the region into blocks, floors, blocks, concrete, grass, and lake. And that is what this bit does. So let's enable that. Oh, no, we don't want to do that. So that's a bit of a preview of something from later. So let's just disable that. Okay. I want to spoil the surprise. So we've taken the path that we're here. We've identified which one of these are going to be the buildings. So again, just quickly, back to the bottom. These buildings are what I'm talking about here. So in this case, we have, go back to Unreal, we've got 5 of them. No, we've got some number of them. It doesn't really matter. And one of the things that we've got over here that I haven't really talked about yet is this notion of parameters in a graph. This is another thing. These are very similar to attributes. You think of them exactly like attributes, but these are just variables that you can store in the graph. So one of these I've got is the number of block repetitions, and I'm using that to say how high these buildings are going to be. So if we take that up to 5, do we get 5? Maybe it's at the wrong place. Wait, give me a moment. Have I done the right thing? That's weird. Have I paused something? Well, oh, wait, hang on, maybe I've done the wrong thing. Bear with me 1 second. Let's just take that.
If you change the default value in the actor that's in the world, it won't update the default in the.
Right. Okay.
So if you have the little checkbox in what's in the world.
Little checkbox that's in the world. So in the
if you go to your PCG component, like the one that has the graph, and go to this and parameter overrides, just below the graph instance.
These. Oh, right. It should be doing well. Maybe it's the wrong variable. It should be doing something. It isn't. Well, we'll work it out later. I'm probably just I'm probably just debugging the wrong thing at this point. So let's not worry about that. Let's just pretend it hasn't happened. I know this works, so it's fine. So
that's part of the PCG experience. Like I lose myself a lot. Everyone does. Like it's just part of the thing. Like let's not pretend it's not.
Yeah, unfortunately. So unfortunately, paths are a bit hard to see. So what we're actually going to do is we're going to turn those into dynamic meshes. And these are a lot easier to see. So this is what I mean about creating floors and creating blocks. So these were previously paths, just abstract data, and now they have been turned into dynamic meshes. And if we go into the world, again, see over here, we've got these set up with collision. I mean, like, I don't know how well you can see that, but like I am actually moving over that. These things now exist in the level. So they look a little bit, I put a bit of a bevel on the grass areas. Let me just turn something off while they've still got. Back. No, it wasn't that. I have to find the thing that's turned on. Where's debugging? Oh, well, we'll leave it on for now. So one of the things you can do with PCGX is that you can take those paths and you can bevel them. So if you're familiar with Blender, well, actually, if you're not familiar with Blender, let's just do it quickly. Because it'll help things make a bit more sense, assuming Blender starts, which it isn't. Oh, no, it is doing. Eventually. There is another node that allows you just to sort of smooth out corners like that. So what is next? Oh yeah, I do want to talk a bit about the dynamic meshes just quickly. So by default, when you spawn anything in PCG, it comes without collision. So if you're spawning, for example, trees, and you don't explicitly say that the tree has collision, people are going to walk through the trees. And I know it's a forest, but you can't actually walk through trees. So you have to be a bit careful of that. Dynamic meshes are slightly more complicated than that because you can only actually apply the collision after the component is created. So you have to have an actor in the world which is listening to PCG or has a function on it that can be called. You add when you go to spawn your dynamic meshes, you specify that actor as a target actor. And as me and Tim discovered from the horse's mouth, that if you call the function here, it won't get called because it hasn't been hooked up full spawn dynamic mesh. That will be fixed in 5.6, we are told. So you heard it here first. But there is this thing apply on objects which allows you to do exactly the same thing. So you have these post-process function names, and I've got a function on there which is on dynamic mesh added. And what that does is it takes the dynamic mesh, it works out the collision for it, applies the collision, and then you can walk around on this stuff. So is this a good time for a quick break? How are we doing for time? Do I need to go faster or slower? How are people finding this? Are you bored? Because if you're bored, we can just like skip to the end. That's fine too.
I doubt anyone is bored. In fact, chat has been pretty active with following along with what you're talking about. If you
They're
need
slagging
a
me off for
short
being stupid
breakdown,
or doing something wrong.
no, no, this is great. Take as much time as you need. We're all here to learn.
Yeah, I suppose so. Um, are there any questions that you want us to go over now? Because like I need a quick break from talking, just quickly, because I need to turn the lights on, because it's getting dark outside. I need to refill my drink, and so if you've got some questions that Tim can take, that'd be really good.
Sure, yeah. We'll toss you to the wolves for a second here, Tim.
Oh,
So,
okay, fair enough.
So one question actually, there's a few people asking if there's a sample project for PCGX or something that has examples of how some of these nodes work as well.
Yeah, there is. It's open on it's on Git. I guess we can share the link to the example project is pretty much everywhere. There's a link to PCGX, so it should be fairly easy to download. I have it on my screen. If you want to switch to my screen real quick. I don't know if people are
Yeah,
seeing this.
absolutely. Let's
Okay,
do
cool.
that.
So there's a few examples that are like actual usable example, but they're not like super interesting. What the bulk of it is more of a sort of showcase of what like the different nodes do, how they can be combined, like what you can get out of them. It's like in a bunch of different folder with like rough category that I'm trying to keep sensible, I guess. So there's a bunch of things about clusters, like more task-specific tools, like the bevel he was mentioning. I guess this part is easier if you go through it on your own computer, and all the graphs are extremely poorly commented, but I'm working on that. So there's a bunch of like stuff that you can try and look at, and so yeah, that would be the example project. Um,
Awesome. Yeah, this is great to know that this exists, just so that they have that context. You can go in and easily see what all
Absolutely.
exactly is going on in there. I have seen also, interestingly enough, a few questions about how much PCGX costs, if you don't mind letting folks.
It's open source,
It's
so
free.
nothing, just time.
Yeah. I love the way that you have it phrased on your page, actually. In fact, specifically that it's a fast evolving, community driven, open source project.
Hmm.
Yeah, it's awesome. This is free. You can just pop in and play around with it. Welcome
Absolutely.
back in.
Sorry, I think.
Like a lot of the reason why it's where it is today is because people just asked for stuff, and I was like, oh yeah, that's actually a cool idea. I'm gonna put that in, and it just grew out of proportion just because people started using it, and so yeah, just
Yeah.
having fun.
Yeah, which is awesome. I have one last question for now. I'm going to toss your way since it's very Tim specific, and then we can go ahead and probably pop back into the demo. But a few folks were curious about why you started making PCGX, or like what's the story behind how this all began in the first place?
Uh, well, at the very beginning, because my partner started spending a lot of time into her home, like she had a book project, and I was left with a lot of time on my hands. And so I thought like, hey, let's make a game. Let's make something like with Unreal because I was coming from Unity before and I was trying to like expand my tool set. And I looked into PCG and the first thing I wanted to do was pipes. And like it proved really hard. I found a GitHub that had a prototype of a sort of pathfinding node in PCG. It was very slow, and I was like, okay, I'm going to try to do something on my own, and started there. Uh, and yeah, like it derailed completely because I think it's still not very easy to do pipes with PCGX, but you can do a lot of pathfinding, a lot of things, and you know, I used Houdini a lot as well. I was trying to bring back some of the thing I loved in Houdini into Unreal directly. So I guess that's pretty much that.
That's awesome.
There's no particular reason, just
You just did it. Did it because you wanted to. That's awesome. All right. Well, with that, I think Ed, if you're up for the next part of what you're going to talk about, or Tim, if you were going to take over, whichever the next bit of the demo is here.
If you talked about the your demo project, which is really cool, then we can go back to doing this. I don't want
I
to keep
did
so.
like there's no very much narrative value into the example project. So.
It's very helpful to have, like context to have for people interested for sure. We just put a link to it directly in the chat as well for those that might be interested in checking it out.
Thank you.
All right. So yeah, Ed, if you wanna hop back into what you're talking about, please feel free.
Is my screen back?
Yep.
Yes. Yes. Okay. So while Tim was chatting, I worked out what was going wrong with those blocks there. So we can have more floors, which is good. And again, if we go, I hope this works. Go play from here. We're on top. You can see our feet, but we're at the top. It's got collision. That's really cool. We've created something actually in the world as opposed to just purely cosmetic. So we are basically done with the no, yeah, that's the macro layout. So we now need to turn those things into buildings. We're going to talk about a bit of grammar. Grammar is part of the regular PCG. It was added in 5.4 or 5.5, I can't remember. But what grammar does is it basically lets you take a spline and split it up into different bits according to certain rules. If you're familiar with regular expressions, I can't imagine why you would be, but if you've done any sort of web development, you might have encountered a regular expression. They're like one of the dark arts of computer science. If you ask me, they can get excessively complicated. The people who can do them are basically wizards. You can do the really complicated ones. But a grammar is like taking a regular, like treating a regular expression backwards, basically. Regular expression will search through a piece of text and identify certain symbols within it according to certain rules. Grammar flips that on its head, and you take take a bit of text and you expand it out according to a certain set of rules. They look very similar to regular expressions, but we will just go into this and we will have a look. So we've got this loop over here. We're going to split this into several different bits. So if you've ever been to the Barbican, it's probably more obvious. But there are different shapes of the building on different levels. So on the bottom, you've got fairly these brown bits. Then you've got these lovely bits here with the window boxes. There is a bylaw if you on the lease that says you have to cultivate your window box in the Barbican. We'll be getting into that in a minute because we need the plants. And then on the top, you've got these curvy things. So we've got a base, we've got stuff in the middle, we've got the top. We need to work out what's where and then put different bits in, essentially. So let's do that. So if we go and we enable these. So, no, let's what bit am I looking at? Sorry, it's there's a lot of subgraphs. I should probably have practiced this slightly more. So for grammar, what you need is this stuff called module info, which has a symbol. It's got the mesh that you want. Well, strictly speaking, these are separate things. I've kind of crammed two different things into one thing here, but for now we can just treat it like this. So in this attribute, I've got a symbol. This is going to be the thing that the grammar node picks out when it wants to say, okay, I need to put this mesh or this particular thing here when it's producing that extra big string. Then we've got a mesh which we're going to place later. We've got a size which says how much space it takes up, and then we've got whether it can be scaled or not. Now, one tip, if you're using grammar for doing anything, you've got to make sure you've got at least one scalable element. It can be really thin, but if you've got that in there, then it will be able to basically fill out a spline of any length. If you don't have that, then you're limited in the kind of size that you want, and you don't really want that for grammar. What you want is to say, I've got a building, it's this size, just make it building-y, and grammar does that. So you need to have that scalable bit. So when it's trying to fill in, like it says, I don't know what's going to go here, like just a bit of wall, you need to have that scalable thing in there. So I've got a data table, which has the symbols that I'm going to use, the meshes that are going to get placed, size of stuff, whether things are scalable, and then, sorry, the cat may walk on the desk.
Surprise guest.
Yeah. He's looking out the right. Okay, so just to warn you, there might be a cat interruption. Anyway, so we've got the base, we've got the bit in the middle, we've got the roof. We've also got this thing that says roof side, which we'll get into in a bit. So I don't want to go spend too much time on grammar because it's not really into stuff to do with PCGX. Again, there's lots of good tutorials for grammar elsewhere, but broadly speaking, we are taking remember the floors that we had before. Each one of those is like a separate data set, so they're called collections, and we take each one of those in turn and we feed them into the thing that basically applies the grammar. This is almost directly out of the docs, the examples that are in the PCG examples, the docs that are online just says what to do. So we say how high we want it to go. This is the extrude vector. We duplicate cross sections. We do all of this. And then we come out of that, if I can remember where I am. Sorry, too many subgraphs. Here we go. No, it's this one. Right, great. Okay, let's tell you what. Let's just smash it. It's not. Anyway, so it goes through that. It applies the grammar and it gives us some points that we're going to spawn. Now, the other thing that I want to say about grammar is that corners are really awkward, and I'll explain why. So here we go. We now have the bits that are in there. So it has taken those blocks, it's looked at the space in between them, it's created a new spline for each floor between these, and then it's applied some meshes that I created in Blender and put them in the right place. And if you look carefully, we've got, is this three? No, there's two different meshes there. No, three different meshes. We've got like one that's got a door, we've got a big window, we've got a kind of split window. And then this is the scalable bit that I was talking about, this gap here. If we look at a different building or a different wall, you'll notice that that is a different size. Basically, that is what the scalable thing is there. It's like glue that you place in between. You can put it in different places. If you put it at the start, it kind of looks rubbish. Put it at the start, at the end, it kind of looks rubbish. You want to kind of like spread it out in between your building, because then it becomes a lot harder to spot. But the thing that you need to worry about are corners. Corners are really awkward. Now, there's kind of a good reason for that. Because what we're doing, we're taking a 2D shape and we're putting a 3D object on top of it. And if you think about, say, this drumstick, right? This drumstick is our path, and we're putting a mesh on top of it. Let's do it that way round. If we put the mesh over it like that, so we have zero like right in the middle. thanks for switching that to the main view as I'm doing this particular motion. So if we put it there, when we get to the corner, we're going to have something like that, and that is going to create kind of a box. If we put it here, it's better, because like we're going to the corner and it's going to line up exactly, but that kind of limits stuff backwards. And it's likewise, if you put it on forwards, that's going to like really pronounce that kind of thing that you have at the edge. So grammar, when you're using the node, it allows you to flag the extremities, and then you can place a corner there. Just expect to spend a bit of time fiddling with the mesh to get it to look right, because quite often you just have to dick around with it. So this is what that corner mesh that I was talking about. If we go down to the base, you'll see that I've not bothered putting it on there. This is what I'm talking about. When we've got this, the front of the mesh is this wall, and this extends in front of it, and then you end up with this. It is slightly preferable to having it behind, because then things clip through more often, in my experience. If we go up to the top, I was talking about those sidewalls. So one of the things you can do with the grammar is that you don't need to apply the same grammar on every bit of your path. You can select different grammars to use in different places. You can put in different meshes. You can do this kind of thing. So when we've got to the corners here, because we have this particularly wide thing going backwards, if this, I don't know how well you can see it, because like the mouse is white and the thing is white. If this thing, again, here's the front, if this thing going backwards was going this way as well, they'd just go over each other, and you don't want that. So sometimes the best thing to do is just alternate between having a really thin wall. If you want thick walls, have a really thin wall next to the thick wall, and then you can have the thick wall, and nobody really notices that the thin wall is there. So basically, we're kind of done now. I mean, the other thing to talk about are these plants. So just quickly, I'll go through this. This is again going more general PCG. Now, you will notice that all of these, like, doesn't seem to be any pattern to where the lights are, right? And that's what you want when you're doing a city scene like this, because you don't want everyone in the building switching the lights on. because that rarely happens. I mean, it does actually happen over there in the city of London. Sometimes you'll go past an empty office and all the lights will be on, which I think is horrible. But typically when there's going to be some selection of people who are home, right? They're not all going to be home. And like if they are home, they're not going to have lights on in all the rooms. So you want to spread that out. Now, the way that you do that with PCG is you have these static mesh spawners. And again, just reiterating what I was saying before, collision is off by default. If you want collision, remember to switch it on. There is this thing, a static mesh spawner. So if we look at the output of this, we've got these points for spawning. It's worked out where to put them. Importantly, it's given them a color. That's something that I did in the loop. So I've got a data table with colors that can be used for light bulbs, like the light bulb that's up there. That's quite a yellow one. There's some slightly more blue ones. If you go to your shop, you will have lots of different color temperatures. But basically, I just got a chart of light color temperatures and just like use the eyedropper tool to grab a few, and then it randomly applies different ones to them. But in your static mesh spawner, you have this thing which is called an instance data packer. And what that does is it will take a attribute that is on the point, and it will, although in this case it's color, which is the property, I'm only really saying that. We'll take that and then it will feed that through to your shader as an instance custom primitive, per instance custom data is what the thing. So if I can find the shader quickly. This isn't the one, but basically you have this notion of, this is like a really basic one that just colors it based on it, just on that. You have this per instance custom data. Now, if you're not familiar with instance static meshes, we are not placing a separate actor for each one of these points. We are placing an instance. So we just got the transform. And that's a lot less heavy on the rendering because basically the way that the computer works, you upload the mesh, you upload the transforms, and then it places them in the transforms. If you're doing that, if you were to do this with per actor, it would have to upload the mesh and upload the transform, and then for the next actor, upload the mesh and upload the transform, and it would keep doing that, and that would get very slow. But as you can, and so we don't want that. We want to have nice, good FPS. You can still apply collision to these things, but basically, if you're spawning anything with PCG, you probably will be using an instance static mesh. So that's just something to bear in mind. Again, this is just something that is a feature of your material graph. So you can feed this in. You can also feed it like, so if you've got some other, for example, properties, you can also feed those in. So in this case, I'm using the color for just the lights. And then on the plants, it's selecting a random plant, and then it's using those for flowers. So there was a very handy sale on Fab recently that allowed me to just buy a pack of plants that look right for the Barbican. So I was very happy about that. But I had to take out the shaders, which is why these are really blocky. But we're mostly going to be viewing it from this distance, so it doesn't matter. But for the plants, I've got a different set of colors that I'm applying. It's just doing the same thing. So that is the instance data packer. It's really, really useful for creating this kind of scene. So we'll kind of rush through the rest of it actually, because there is the payoff at the end that I want to get to before I lose my ability to talk because my voice is starting to get a bit hoarse. So we want not an error. Do we need to enable that? Why is that enabled? Okay, so that's bad. Why have we got enabled the block ceilings? I presumably disabled something somewhere. That's what we needed. Has the error gone away? Yes, the error's gone away. So we don't really like the idea of having floating buildings. So we want to have pillars. So this just quickly does that. So there is a node in PCGX which is called offset. And what that does is, if I can find it, where are we? Right, so it's, yeah, this one. This offsets. So if you've got a path again, we'll use the philosophy book for this. If you've got a path and you want to make it smaller, you can offset it inwards and it'll go like that. If you want to make it bigger, you can offset it outwards and it'll keep the angles. It didn't always work. When I started using it, it didn't work properly, but Tim made it work. Um, that was causing me real headaches, and I'm really happy with that he did because he's such a good guy for doing that. But it works really great now. So in this case, we are just offsetting inwards. So we say we're going to offset by 750 Unreal units. Remember, those are in centimeters. That's 7.5 meters. And we invert the direction so it goes in. By default, it goes out. If you invert it, it goes in. That's it. And then we use that to put some pillars in, and now it looks like these are actually standing up. Without it, like, it wouldn't make sense. They'd just be floating. And I know that there are games that have floating islands. This isn't that kind of game, right? So bear that in mind. We'll get back to that in a minute. So then we've done that. Then we can do some more decorations. So let's say we want some lily pads. This I'm referring to as the water forest because, like, this is just doing the classic PCG forest spawning. So we have these lily pads. It's just putting them in space, saying whether they're there or not, changing the scale and the size, and they're there, but they're only appearing on the water. And we're using PCGX to guarantee that anything that we say as a lily pad would just guarantee that it's inside one of these things. Because one of the things you can do with PCGX is this notion of path inclusion. So it will scatter a bunch of points around, and then it will check whether it's actually on one of the water paths. And if it is, then it gets to stay. If it isn't, then it discards it. That's another really, really handy thing. When you're doing this kind of thing, it's very useful to be able to say what any point on the plane is. So if you're putting something somewhere, you can say, is this a road? Is this grass? Is this something else? But you need to have a way of getting that information. It's not super obvious how you get that just from the points themselves. But using these the path inclusion filter, we'll talk about maybe Uber filters in a minute. You can say, well, okay, I've got this point. Is it inside what I'm looking for, or what is it sat on? And then you can get that data out, and then you can react to that accordingly. And that's incredibly useful. There's probably ways to do that with the native PCG. I will say it's slightly easier. I was gonna just quickly, did we turn on the grass? No, because that's the wrong thing. Oh yes, sorry, this one, right. I'll just run through this quickly. Again, I was talking about static mesh spawners. There are different things that you can use. So you don't have to use an instant static mesh component. You've also got the option of using a foliage one, a hierarchical one, which just look it up, or the regular instant static mesh component. I wanted some grass, so I'm using the foliage one. And if we go back to this, executes the PCG task, we've got grass on the grass. It's not just green. I'm doing some stuff here, a bit of spatial noise to sort of change the level of it so it looks a bit patchy in places. But you don't need to worry about that. And again, if we go back to this, again, this is all in real time. It's all happening. Pick up your cricket bat, and this has got some grass. It's a bit long for the Barbican, I will say. The Barbican do keep their lawns much better kept. This is a bit shaggy. It's starting to look a bit post-apocalyptic. But again, this is kind of getting pretty good, I would say. This is sort of getting towards the end. So let's just activate these because, like, we've already talked about the grammar. Grammar doesn't need to go along the side of buildings. It can just go up or in any direction. In some of the is it the Cassini example? There's a example of grammar for laying out corridors. So it's not just like stuff around. You're not just limited to buildings. There's lots of other stuff you can do with this. In this case, I wanted to create the towers for the Barbican. So let's just I think, where's Shakespeare Tower? That is Shakespeare Town. By the way, if you're in London, this is Whitecross Street. There's a really good street food market here. But anyway, we'll come back to that later. So this is Shakespeare Tower. You can see that it's got like people say that the Barbican is bruceless because it's made out of concrete. It isn't really bruceless. It's far too ornamented. That is probably a discussion for a different live stream. But like it's got these things have got a very distinctive shape. So I just wanted to capture that. What I did is like I modeled this in three parts, so like like three sides, and then I'm basically placing those just going up. So rather than around, we're going straight up. So let's just switch those on and see what it looks like. Now there are only three in the Barbican, but we want to be better than the Barbican. We want to be the ultra Barbican. So we've got more. We've got Shakespeare Tower is one of those. We've got all of the other English writers basically. From like all English writers pre-1950 now have a tower named after them in the Ultra Barbican, not just Shakespeare and whoever the other ones are. So, but again, this is grammar. So same principle as placing stuff around a path, but we're just going straight up. Because if we look at the mesh that I'm using, quickly, meshes, buildings, Barbican, go to, like I said, we're not explicitly not placing stuff around. We're just placing a chunk of building, right? And we're doing that 3 times, just rotating it around. So that's another way that you can use it if you want to make buildings a lot quicker. Rather than worrying about that at all. If you've got a particular shape of building that you need to extrude upwards, just do it that way. It'll save you a lot of hassle. So that's that. Okay. Let's also, because we want to make it look a bit realistic, I mean, a bit realistic, or rather, we don't like the idea that there's just kind of wasteland beyond. This looks a bit too cursed earth, if you're familiar with Judge Dredd. This is a bit too cursed earth right now. And I'm not saying that outside of London is the cursed earth, right? Just to be clear. But it isn't. Okay, right. It definitely isn't. So let's go back to this. We want some other stuff in the background. We just want to fill out stuff in the background. So it is just worth highlighting with this that you can get away with quite a lot in PCG just by using cubes, right? The big thing for procedural generation is just this idea of visual noise, just breaking up patterns, breaking up sort of like obvious repetitions. And so if you want to have a load of distant buildings, just shove a load of cubes in. So that's what we're doing here. It's just a load of cubes. They're different colors, they're different rotations, they're different heights, they're different widths and stuff like that. We just add a load of noise on top of it, but we'll just wait for the autosave to finish. We go back over here. I mean, it just looks more like a place because it just breaks up the vista a bit. So let's head on. We will now. I was talking about killing a few birds with one stone. So we'll just do a quick bit of self-promotion. One of the things that you've got in this game, or will have in this game, you have this kind of like essentially a high-tech cricket bat. And it's got some kind of unexpected features in it. So, I mean, we've got the obvious one, which is a grappling hook, although that's decided not to. Well, we need to grapple up. But the more interesting one, it's got a pogo stick. So this I haven't quite decided if I'm going to keep this, but I really like the idea of just like it just strikes me as being absurd. And I want to be able to play test this and just sort of like have some sort of assessment of like what kind of bounce amount do I need for this? What kind of like, how should it respond when it's sort of going on different normals? This kind of stuff. And so I've stuck this stuff in, basically. So again, this is just cubes. We've just plonked down a bunch of cubes. We've used a bit of spatial noise. Spatial noise is just, I was going to say spatial noise is just Perlin noise. That doesn't help much if you don't know what Perlin noise is. Spatial noise is a node that produces noise that smoothly changes over a region. Um, and there's a few implementations I think that you can pick from, but the idea is that rather than having like a kind of like really harsh transition between different parts, you want it to be kind of smooth. So I'm sort of using that spatial noise to kind of vary the rotation and the pitch. So it kind of goes smoothly. It just moves like a wave essentially, as opposed to just everything being at random different angles. Now you can do that as well if you want, but I wanted to do that, so that's what I did. Now we've now been talking for an hour and a half. So is this a good time for another question break?
Yeah, I mean, we can so a lot of the questions that I'm gathering are kind of just generally across the topic as a whole. So I suppose it's more, is this going to be a short break because you have more things that you intend on talking about and you need a moment to rest your voice because you've been talking for an hour and a half?
There's basically the finale. So it's like, just save the best till last.
Yeah. I gotcha. Okay. Yeah,
Arguably.
we can take a couple questions, give you a second to rest. Um, which thank you both genuinely so much for doing this and talking about this. It's been really cool being able to see the ways that this plugin expands on base PCG and really does give it a lot of kind of quality of life extensions there, which are really, really nice. So first, thank you so much for doing this. Um, First couple questions I'm going to toss your way. One that's come up several times is folks are curious what kind of hardware you're running this on because it's running very smoothly, and they're curious, especially with so much PCG being used in the meantime, how you've got your rig set up.
This PC is a bit old now. It is a 3080 Super, so it's not a super recent GPU. It's one of the top end ones from 5 years ago, but like I've not needed to replace it. So yeah,
Very nice.
I say it's one of the top. It's not the top end. It's like the great one as opposed to the amazing one. But yeah, it's 3080.
Yeah, so pretty good. I feel like in the world of tech, as soon as you say like it was really good 5 years ago, everyone's like, oh, exactly 5 years ago. But no, that is still a pretty good setup there. But it is good to know that it runs this smoothly, even without the stuff that's come out in the past 3 months, the absolute latest in inventions. So that's good context to have. Next question I've got here for y'all. Some people are curious if there's something like a roadmap for PCGX or if it's more just you make the stuff that needs to be made, that people feel like needs to be made. I think you're muted there, Tim.
Indeed, it had to happen. So no, there's no roadmap. I do a lot of stuff on a per need basis, I guess. Um, so yeah, no roadmap. The most tricky part is I'm trying to maintain the plugin for back to 5.3. And so there's a lot of new features that I can't really leverage that much because there's been so much change in the code base between 5.3 and soon 5.6. Like I know 5.6 is going to be like its own branch because there is no way like I can just keep adding more and more code for every single version in the same code base, which is what I'm doing right now. Uh,
That's
but
fair.
no, I build the thing pretty much as we go.
Awesome. Um, just because I'm curious about this, when you do add things in, is there anywhere that folks could keep up to see what is included in the latest updates? Would that just be on GitHub, or is there another place where it's good for people to follow your work?
Mostly Discord, I guess. Like I'm gonna usually send update to Discord on stuff I'm planning on doing or actively working on. Fab, I'm trying to keep it up to date to the latest on Git. So I'm trying to have everything at the same level, and if there's like more heavy changes, they're usually in their own like separate branch until it's stable, and when I bring it to the main repo, I dispatch the update pretty much on everywhere, on Fab, on Git releases, and so yeah.
Awesome.
Usually what's on Fab is the latest on Git.
Awesome. Good to know. Good to know. All right, then the last question I'm going to toss at you for now. I know there are more. Nobody panic. Don't worry. Still going to ask them just at the end. Okay. Don't want anyone to be like, no, she skipped mine. The next one I'm going to toss at you here is folks are curious if you have something like an official YouTube channel or places where you post tutorials, or is that something you would consider in the future?
I might considering. I don't have a YouTube channel right now, because developing the plugin is taking a lot of time, and
Mhm.
making the documentation has been a fail. Like it's not even something I can keep track on anymore. It's just like there's no documentation. So doing that well takes a lot of time, and I don't know if I have the time so much. So I guess I'm gonna try to find more like partners, like Head, for example, or like we'll see what comes up in the
Don't
future.
look
But
at
yeah,
me.
like
I've got far too much stuff to do.
that's not what I was implying. Like, do you
Awesome.
know what I mean?
Do I? Yeah, okay, I do. That's fine.
Don't
Well,
do that.
I
We're
mean,
alive.
like I said, I've been started writing blog posts on this. I've been a bit stacked recently because I've just been trying to meet. Well, there's been various things to apply for in terms of funding opportunities and stuff. So I've mostly been working towards that, and then also working on the game a bit, and then also getting this ready and stuff. So maybe I will revisit that. But generally, if you join the PCGX Discord, there's a bunch of very friendly people there who can answer your questions. Unreal Source is also really good for just more general PCG stuff, I would say. There is a procedural, is it just PCG framework, the channel
Yeah.
in there? Yeah, so join those, but particularly start with, I would say start with the existing PCG tutorials first, because there's a lot of prerequisite knowledge and stuff that you'll find it a lot easier to pick up the other stuff in PCGX if you've done that first, or if you've got a really strong background in Houdini, maybe you could do it. I don't at all, but maybe you can just jump straight in. But yeah, I'd start with the regular tutorials first, and then move on to this stuff because you need to kind of get some sort of sense of how the framework hangs together.
Yeah, absolutely. Totally agree there, having some baseline understanding. And just to add in a thing from the community side too, we do also have some tutorials around PCG available on the Epic developer community as well, that is specifically centered towards beginners of the tools. So if this is just kind of harkening back to when we did our post between 1 and 5, how much experience you have with PCG, I did see quite a few ones in there. So if you're new to these tools and you just kind of want to learn the base functionality of them, really highly recommend checking those out as well. I'll see if I can't find a link and toss it in chat there for y'all as well. In addition to, we posted a link to the PCGX Discord, so check that out and we'll get something for Unreal Source in a second here too. All right. Well, with that, I think I'm going to keep the rest of the questions in my back pocket for the end segment here. If you're feeling up for the finale, Ed.
Yeah. Okay. So if we go back to now, at the moment, let's just recap where we are. We've got some buildings, but there's nothing really connecting them. And one of the things Barbican is kind of famous for is that there's these high walks, these sort of like elevated sections, these kind of streets in the sky. There's other large housing projects that are in slightly less posh areas of London where they tried to do that, and it was a terrible idea. But in the Barbican, it really works. So we need to put in some walkways and stuff. So that is what we are going to do. And this is also probably the most complicated bit. So let's enable this. So we want the walkways to go through the middle, right? Um, and we want them to connect the buildings. So we need to know where the buildings are. We need to know where the middle is. We need to have some sort of points in between where they meet. So how are we going to do that? Now, I've put this note here saying that the scale is based for different scale for the base is different than the scale for the upper levels. It isn't anymore, so just ignore that. So what we're going to do, remember we had that in a square. I tell you what, probably the easiest thing to do at this point is just show you what we're doing, then I can talk you through it, rather than doing it that way. So if we go through, we now have walkways. And again, this is all PCGX. So how have we got here? That's the kind of question. So we've got the walkway. It starts over here. You can see it branches off and goes over here. I mean, like they're not on top of each other. It has actually created a network of stuff, and there are support pillars and so on. So going back to this notion of clusters, what we're going to do is we are going to take that square that we talked about at the start, that kind of like inner square. That's the bit that all of the buildings are around. We're going to use this node, which is subdivide. So you take a point and you just divide it, so it's got more points on it, and that's really, really useful because like sometimes you just want to cut things up in different ways. Now we are then going to put everything on the floor. So we're going to set the actually no, sorry, that's the rotation. We'll do that in a second. So we're then going to make a grid for the subdivided points, and if I enable this, and then let's just turn these off so we can see things a bit better. Right. You will notice that like the tasks are starting to get a bit excessive because we're doing quite a lot of stuff now in terms of just programming stuff. So we've got these. Let's just quickly get rid of our dynamic meshes. Okay, that's better. So we're creating a grid that goes between all the different buildings, and it's just keeping the idea is just to keep the points where this grid is touching a building, pretty much. So we are going to use, if I can remember what the bloody thing is. Do I need this anymore? No, we don't need that anymore. Let's just close. So I'm just going to close some tabs because this is getting annoying. Need that. No, we don't need that. No, that. Don't need that. Also don't need that. We'll keep that for now. Sorry, talk amongst yourselves. Right, okay, yes, we do need this. No, we don't need that. We need that and this. This is where we were. Good, okay. So again, we're going back to this notion of creating clusters. So we're creating another graph. In this case, it's a grid. And in the grid, we've got the nodes, and then we've got connections between them. And what we want to do is use that to create something that isn't just a straight line across, because straight lines are rubbish. In this context, I'm not saying straight lines in general are rubbish. I'm sure there's lots of very good straight lines out there, but for PCG, straight lines, no. So we want to make sure they don't go like in an entirely straight line because it's just less interesting. So if we go, God, I've forgotten where it is again. Too much stuff. Right, let's just move this over here so I don't forget where it is. So we create the grid. And then what we want to do is we want to refine it a bit. So we want to get rid of some stuff that's in there. One of the things you can do, again, this is another PCGX thing, is that when you've got your clusters, when you've got your graph, you can use filters to refine it. And that's exactly what we've done here. So if we take the output of this and then enable it and then click on the right tab, we have got not the interesting thing that I was hoping to show off. So we'll forget that that happened. Get rid of that. So sorry, it's a lot of stuff going on here. Anyway, so we've refined it somehow. I can't remember exactly what that does, but it was really good, and I'm glad that I did it. So then we take the blocks. We've got this again. When I'm referring to the inner quad, I'm referring to that square that like sort of encloses the lake. And we are using. I don't think we've actually touched the Uber filters yet in this demo. These things are like the other super handy thing that you can do in PCGX, because in regular PCG you've just got. Actually, let's just do I think filter. You can filter on stuff. Actually, let's pause that. But each one of these filters can only really do one thing at once. So if you want to combine filters, you wind up having quite a long string of these things, which is fine. But with PCGX, you've got this notion of separate filters. So you have the node that does the filtering, and then you create filters that you pass into that, and you can combine them. So you can like have the OR operator, you've got an AND operator, and that makes life so much easier, because like rather than having like a long string of nodes that you're sort of putting together, you can just have a dedicated filter. And another thing you can do, if you like that filter, you can. This is a native PCG thing. You can add named reroutes. This is it's basically like best think of it like a local variable in Blueprint. Put it that way. You're just taking the output of something, giving it an alias, and then you can use that elsewhere. So over here we have this that says block roofs. When we've got the input to the graph, we're just storing that, and then we don't need to draw a line between it. Because the other thing that I really hate about Blueprint sometimes is just all the lines, and it gets really spaghettified, but doing this allows you to break it. So what are we doing with this? Well, we're basically filtering out certain points. One of the things we're doing, we don't want stuff to go in a straight line, right? And if to go in a straight line, it would go straight through the middle. The other problem with going straight through in the middle is that it would hit the lift. And I like the lift. It's a really good lift. It's another procedural thing. It's not using PCG. It's just a really cool lift. But we don't want stuff going through the lift, right? So we're going to check the distance away from the center. So with that, one of the filters is distance. So you can just say, I want this point to be a certain distance away from something. When I'm doing create points, I'm just creating one point just at the origin. So it's not doing anything. Basically, what this is saying is like, if it only keep a point if it's more than 2,500 units away from the origin. So we get rid of some of the vertices in here, and then we use this other node, which is called sanitize. So basically, once you've got rid of a bunch of vertices, you've got each one of these classes has got a vertex output and an edge output. If you get rid of some of the vertices, some of the edges aren't going to have endpoints, and then you're going to start getting errors. So what this sanitize node does is just make sure that all of the edges that you pass in have an associated vertex, and then gets rid of them if they don't. So if we enable that instead, and I should be using the shortcut Tim mentioned, but let's just forget that for a second. Enable that, we can see that we've got a gap around the edge. We've got rid of the points that weren't touching a building. So everything is either inside, in which case it can be used to sort of navigate through, or it's touching a building, in which case it can be used as an endpoint. And then what do we do next? So there is this loop here. Do I need to explain loops? I'll not explain loops. Loops, actually, no, I will explain loops, but I'll do it really quickly. when you're doing stuff with PCG, you're always or almost always processing like lots and lots of data at once. So all of this data comes in a collection. This is the collection. So any operation that I do on this gets done on all of the members that are in it. And we've got a whole bunch of them. So if you're thinking about loops and you're thinking about loops in Blueprint, for example, you'd loop over an array. That happens by default in PCG. What you use the loop node for is to split these different collections away from each other so you can consider one at a time. Because sometimes you just need to do that. Sometimes you just need to say, I just want to focus on this collection and there's some particular property I need to extract from these one at a time as opposed to over the whole thing. So we have a loop. And what we are doing basically is we're taking the stuff that is now gone very thin, that's out here, basically the points and the edges that are over here. And why is there an error? Ooh, something's gone wrong. I hope this works. Oh, wait, hang on. Should we enable that? Why is there an error? I probably disabled something, but we'll see what happens. Maybe there'll be another error. So we're taking those points, and what we're doing is we're trying to pathfind through them. Now, in PCG, there is a pathfinding node. In PCGX, there is other pathfinding stuff that you can use. But it uses the cluster explicitly. It uses the graph that you set up explicitly. So it won't try and pathfind. In regular PCG, the pathfinding will just do it by proximity, I believe. Is that right?
I think there's a slightly more than that, but it's mostly proximity. Like it's going to probe what's close enough and try to connect to it if it has a good score, roughly.
Yeah.
But
Well,
it's mostly
apologies
yeah.
if I'm wrong about that. Sorry, but it's slightly more limited. In what we want to do is we just want to use the grid that we set up, and we want it to only go over the edges that are there. We don't want it to go jump across a gap, for example. We want it to say these are the places you can go, and that's what this plot edges thing does. So we're going to be plotting a lot of edges, and each time we use one of these plots, that's going to become one of the walkways that we create. So that's extremely useful. There's ways you can customize it. It's got these heuristics, which is a very expensive word, but it basically means sort of guidelines or sort of hints for the algorithm. You've also got the choice of two different algorithms. I mean, do we need A star and Dijkstra? I'm not saying it's bad. I'm just this is actually me
It
asking
actually
them.
yields slightly different result based on your actual setup. Like usually A star is faster, but it works better with very like sort of stable grids. Dijkstra is better when you have like really odd connectivity, like very long edges connecting to very short edges, and like if you want to tweak more heuristics, like I like Dijkstra better, but I guess it's just whatever works for you, I guess.
Well, I mean, Dijkstra does have the cooler name, and you get extra nerd points if you pronounce Dijkstra right because it's totally not spelled like that. So anyway, that's basically all we're doing. We are plotting a bunch of paths between the places that we set up, and we just do one per block on each level. So again, we've got on each one of these levels, it's going to pick a start point, and it's then going to try and pick just a random endpoint on another block, and then it's going to pathfind over to that, and that's what we've got. So that's cool. And then we have to do a little bit of extra processing on the other side of this, if I can remember where it is. That's saying error, so I'm going to delete it. That's always the best thing to do. There's another error somewhere. It doesn't matter. Anyway, so we've got a slightly interesting problem now. Have I disabled the right things? If we go back to this, you can see that when we've got these intersections here, this one's okay because there's a path coming in from each side. This one isn't. It's missing a wall, and that's dangerous. Someone might fall off. So what we need to do is, and it's the same with, I got a bit fancy and I put in two different types of walkway because these are more accurate, but these were kind of like easier just to knock up. It's the same problem here, although that shouldn't be shadowing, but like as we go up, we should be able to spot other ones. Over here, we've got two missing walls because it's on a corner. So basically, we've got to fix that for health and safety reasons. So we now get on to probably the most complicated thing that is going to be in this presentation, which is this notion of node flags. What you can do with PCGX is that you can take your cluster and then you can flag nodes based on filters, really. So again, like the filter before, rather than say, I just want to get rid of the stuff that doesn't pass the filter, you want to flag that. What this also does is it does it with a bit mask. Now, we've had some fun discussions about bit masks. Bit mask, if you're not familiar, is a way of packing a load of different Boolean properties into a single value. And if you're familiar with binary, which you should be because you're watching something about computers, you can think of a binary number as a string of ones and zeros. Now, what you do with bit flags is you say, I'm not going to treat that number as a number. So I'm not going to treat that as like a string of ones and zeros that translates to a number. I'm just going to treat that as a string of ones and zeros. But it's still kept in memory as a number. So what you need to do is use various bitwise operators to set and read those flags. Now, they're very powerful because they allow you to pack a lot of stuff into one thing. It also lets you read lots of variables at once. They are just very confusing to think about if you haven't encountered them before. And
even when you did,
sorry,
even when you did, like I still get totally confused about them.
Yeah, so I mean, if we look at, it's easy when we're thinking about these ones, right? So if we look at the value of our plus X flag, it's 16. That's good. This one's 2. This one's 4. And this one's 8. Those are all powers of 2, right? Which indicates that we are putting a 1 in a particular point in our binary, because binary is, as you well know, is numbers written in base 2. So the first bit is 0 or 1, which translates to 0 or 1. Second bit is 2. Third bit is 4. They're all powers of 2. When we look at the endpoint one, though, it says 256. Actually, that's not as confusing. No, actually, I made this less confusing specifically for this talk, and I forgot about that. So never mind. It will get more confusing in a second. So basically, we're saying what I'm doing here is saying that I want plus X to correspond to this particular bit. I'm saying minus X is going to correspond to this particular bit. Same with plus Y, same with minus Y. Same, and if it's an endpoint, it's a really big bit. Well, it's 256 is 2 to the 8? 2 to some number. Anyway, so that was a guess. If I'm wrong, please let me know in the chat. I will hand my degree back, I suppose. Now, we take these things and we then create a node flag. This is where it gets slightly confusing because we've got the bit mask, we've then got the type of filter, and then we're using that with a node flag to construct something that then gets sent into the flag nodes bit. And that's a lot of nodes, right? But it is handy to do it that way because it means if we wanted a different type of filter over here, for example, this one, and we wanted to tie that to this bit mask, then we can do that, and then we can treat them all as the same thing. And then when we're reading from this, we can actually read lots of different things at once just by constructing the bit mask that we want to look for, doing a test for it, and saying, well, this is our thing. And so that's what we do. We flag the different nodes. If we, it's probably illustrative to look at the output of flag nodes, because if we look at the flags over here, they've stopped being powers of 2. Now, this isn't like all of those things. Well, actually, no, it kind of is all those things added up. What you can do is like there are operators for numbers that allow you to test whether a particular bit is set. You don't need to worry about those. Just be aware that they exist. And then we have flagged our nodes because again, what we wanted to do was we wanted to say if this is missing a wall over here, I want to be able to put a wall in. So, and if it's missing one over here, I want to be able to put a wall in there. And so this one will receive the, what direction are we? This one will receive the -y and the -x flags. If we look over here, this one's just going to get the -x and so on and so forth. And then we can use that, if we go to the right one, to start enabling these things. That is the, which one's that? Right, so we've also got the endpoints. So this is, so I put a note for myself, explain why we're doing all this before activating these. So if we enable these, and then let's just enable the rest because it's not really worth talking about. I've also done some work to put in the supports, because if you've just got a walkway made of concrete floating over nothing, it needs something in the middle. And then there's some other logic that's in there just to make sure none of them are colliding. That's basically it. But I'm not going to make this public. This can be left as an exercise for the reader or the viewer, as they say. Because this is an environment, again, that I want to use in the game. It's really handy having all this stuff, and I'm not just going to give you my source code. Tim is, and that's really good of him. I'm not, apart from the stuff that I've also uploaded to PCGX. And then there we go. We've got a bunch of walkways. If we go, actually, let's just put the rest of it in so we can see the whole thing before big finale. So let's just make sure everything's enabled. Turn our dynamic meshes back on. Pillars, is there anything interesting over there? No, we've got everything. We've got zone. We don't need that. So if we go back, so the view then we've got a Barbican Center. So, I mean, that's pretty cool. We can go in. And I did say I wanted to talk, thing picks up. So I wanted to be able to, test the grappling hook. It needs a bit of work. This is probably a bit too much force. And go over here. This is the kind of thing, the leg animation really needs fixing because, if you're falling off a bridge, you're not going to do that, are you? Oh dear, I've fallen from my death. Does it matter? No, I'm still attached. Anyway, it's a bit buggy, but with this now, it means that I can sort of tune these variables in an environment that just keeps regenerating. I can give this to people to play test. I can say, just give them a button that they press that allows them to generate different bits of it. And then, say, just, go crazy. Find out how easy it is to do. Use the pogo stick. Use the pogo stick whilst grappling. Swing from stuff between stuff. Check out the air control. Find all of this kind of stuff. This is really useful. It's going to be great for playtesting. And also, I've got just a really cool looking environment. And you might be thinking, that's great. Could you just model that? But that would have taken ages. Again, if I wanted to pay an artist to do something, I don't want to be paying them for placing 10,000 walls. I don't have that. I don't have money to spend. If I'm paying an artist on some art, not like lamppost placement. Not that lamppost placement can't be art. It just usually isn't. And the other thing you can do is that you can just really impress people by saying, we had that thing saying block repetitions, and we have floors per block section. So just to go over that one, we've got 3 floors for each thing here. So let's just change some of those values. Let's change that to 5. And let's be conservative and say 20, because I don't want it just getting too slow. And then we wait. We wait for the generation to happen, which might start taking a while. So this would be a good time to start taking questions. And that's it. That's all I've got to talk about. Tim's answering the rest.
Fantastic. Well, thank you for walking
Well, I
through.
mean, I would like to just plug the before I, get on to the real questions. I just like the store page went up this morning. It is called The Last Gig. There's some screenshots. You might recognize this because I am actually going to be using that as an environment. And yeah, there's some robots. And you've got to avoid them, and you've got to get through London. You've got to put on the humanity's last ever rock show in the face of an AI apocalypse. Please wish list it, sign up to notifications and stuff like that. Okay, now we can have questions. Now I've done my promotion break. Thank you very much.
Awesome, awesome. Well, thank you so much for walking through all that. Like I said, really do appreciate having the context and being able to actually see how a lot of these nodes and functions actually work here live. Actually seeing it use an example is really helpful for that context. So really appreciate you doing that.
That's all right. Good to be here. It's not every day that you get invited on an official Unreal stream, so you just have to kind of take these opportunities as you get them, I suppose.
Well, I appreciate it all the same. So, a couple
Thanks
extra
for having me.
questions, that we've been collecting here for y'all. The first one that I want to tackle, besides, of course, Ed, your game that you were just telling us about, the last gig, and everything that you were just walking through,
Yeah.
they're curious if there are any notable cool examples or implementations that either of you have seen users make with PCGX, just as like other potential examples for people to think about.
I don't know of anything that's easily available or public. Ed work is the main thing. uh, no, because like a lot of it is private or under NDA or under because since it's lacking so much in example and documentation right now, like you need that sort of Houdini bit to just be able to be like, oh, okay, I recognize those things and I'm gonna be able to use this and that. And so those are usually more on ongoing productions, and then people who are used to that kind of things. And sadly, the game industry is extremely secretive, which I find a bit sad. But yeah, short answer is no. I guess I could have said just no. Not yet. That is. Uh,
No, yeah, I
uh,
totally understand. I think this in particular that we did get to see was very cool and interesting because it was urban instead of trees. Like we've mentioned before, I think most people associate the tools with that. So seeing it used for buildings and lines and things like that is a really interesting way of seeing the tools utilized.
I mean, it is just worth thinking about stuff that you can do other than forest procedurally. There's lots of stuff that you could potentially use this for in terms of like interiors. So I mean, I'm one of the things that is going to be in the game is a supermarket, and I'm just going to use this kind of stuff for that. Because again, like I'm not going to sit there placing bottles of milk everywhere, but you can say, well, that's a shelf, milk's on that shelf, or distribute products out the store. That's pretty easy to get set up, and then you get a kind of like interesting environment. Those walkways were based on an idea I had for doing ducting for the roofs of like sort of warehouse type buildings or again supermarkets. So there's just lots of different things you can do. If you're just prepared to think about, well, what can I do if I just try and scatter a bunch of stuff? Um, just think about like what kind of effects. And like the thing that helps me most if you're trying to think about these things is just go and look at the thing that you're trying to build. Have a think about like patterns that you can see, regularities, that sort of thing. And then you should be able to get some sort of sense. of a way that you could approach it. It might not be perfect, but that gives you a direction. That's how I do it. But like, unfortunately, in general, examples for this stuff are a bit thin on the ground.
Mm.
Sorry.
Yeah, definitely.
But Tim's
'Cause
example for it is pretty amazing. It will
it's
definitely give you up.
very
It's
it's
comprehensive.
yeah, it is, but it's more of a showcase of feature because the whole toolkit is very low level. Like it's really hard to say like, hey, there's this node and okay, how can you show me like a visual expression of what it does? And like not really. Like you need so much context around it that it's tricky to demonstrate in fun ways. So thanks a lot for managing to actually doing that.
Yeah, yeah. I feel like that actually leads perfectly into my next question, which I feel like I have to state that Ed didn't know I was going to ask this next. It just truly ended up working out this way perfectly. But there was also a question about generating interiors. And specifically, some folks are curious if either of you have opinions on stuff that you think, when it comes to creating and generating interiors, is better to use something like PCGX or PCG tools versus just setting up prefabs that get randomly generated instead.
I mean, you can do both. If you know basically, if you know how big your prefab is, and you know how big the space between them need to be, then you can use all this stuff to lay them out. So it's not really an either or thing, I would say.
Yeah.
Um, Tim, you've done more PhD, so maybe you've got a good opinion on this.
The first thing is like PCGS is really built on top of PCG, so there's no really is it PCG or is it PCGX? Like I'm really piggybacking on the PCG team's work here. The second is there's something we haven't talked about in this demo, which is the level instance based workflow for PCG, which really allows you to basically create prefabs and then use PCG to add variants to them. So you get like 100% control as an artist, and you just like toggle on and off like certain features based on filters that you can set up procedurally. So like there's no like it's just like whatever suits your team and your needs and your scale. There's not one good answer. Like, as long as it's PCG, it's a good answer.
I appreciate that. I'm gonna take that sentence and I'm gonna send that to the PCG team and they're gonna smile. This is awesome. Yeah, I also agree, just kind of piggybacking off of what you were saying, of that it does not have to be one or the other. I think they can both work together quite well, especially depending on what it is that you're tackling in particular, especially
Mm.
if it's something like a city, for example, and you want to have a lot of interiors generated quickly that you can move around in between. I feel like that would be a really good workflow for something like that.
But
But
there's a oh, yep, sorry.
no, please, what were you going to say?
Now, that there's a lot of other pipeline consideration, like how do you load the things? What kind of persistence do you need? Like you could use runtime generation with PCG to generate a room, but can you do it on runtime? Can you afford it? Do you need the room to be that one mesh? In which case you can still export it as a baked dynamics mesh that you build using PCG, but yeah, there's so many layers of constraints that you need to account for to answer that. Like it's extremely project specific. Um,
Yeah,
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 that's just what
for
I
sure.
wanted to add.
Yeah, no, it's a good point. I feel like most of the answers to a lot of these questions ultimately can come down to maybe. Like, it is very
Try it, measure it, and
yeah. Exactly. So yeah, if it works for your project, give it a try? Question mark. Yeah, awesome. So speaking of cities, in fact, there was another question specifically about since you tackled uh making all of London, for example, when when you scale this up for something like a whole city, do you recommend tackling it regionally to give it a more natural feel? I know it's a little different in your case because you are making a city that exists, obviously. So you can't necessarily just let your imagination completely run
Yeah.
free. But in the case that it wasn't something that already does exist, would you recommend tackling it regionally to give it a natural feel, or just kind of letting it run wild, seeing what happens?
Well, I mean, I'd say, I mean, the way I approached it was to, because like what I built, there's the shape of the river, but the rest of it is just totally made up. I mean, it's just like a bunch of points spread across. It's not actually London. It's just something that, from a particular viewpoint, looks enough like London that I can get away with it. Um, but the way that I was thinking about it is like, I have sort of regions for parks, regions for like financial regions for like low housing regions for sort of social housing. Like I came up with like sort of five or six, and it just mostly randomly splits them out, but it puts the financial bit in the middle. Um, and then that's kind of all you need to do. So actually, no, that isn't all you need to do. Then you need to do all of the rest of building the city. So forget I said that. But that's the way I would approach it, is to sort of like have broad notions of regions to give some sort of like variance over the whole thing. I mean, if you care about how it looks kind of close up, then you're going to need to do a lot more work than I did. I will also say that because like I did some experiments with getting all that to spawn in real time, and it kind of works if you only have one building type. And if you started to add more that you kind of need um, to make it look not like, I don't know, a barracks, then then it started to like there's a lot more processing required, and it just sort of like started adding up and adding up. So yeah. The way that I tackled it was more I'm picking a viewpoint, and I can pick any viewpoint I like, but once I pick that viewpoint, I'm going to generate stuff out from that viewpoint at different levels of fidelity. So the stuff that's close to the viewpoint gets the high quality grammar stuff. Bit further away, it switches to just static meshes, and then really far away, it there's a thing that I did that takes the dynamic meshes that it would create, merges them together, and then saves them on the disk as static meshes. So although I can move that viewpoint, it starts taking a long time to generate. I can do it, and I will be doing that for different viewpoints, but it's not a kind of real-time thing, although you can view it in real time. And the stuff that you just saw, that was all real time. So you can push it pretty hard. So don't be afraid to do that. The other thing I'd say, if you're building a city, remember to put trees in. I know we've been talking about how cities aren't like,
No, no
but
trees, Ed.
oh, dude, like it's amazing how green cities are compared to the countryside, and that's not a weird thing to say. I mean, it might be different in America, but in the UK in particular, a lot of the stuff that is around is farmland. So all the public parks tend to be in the cities. There are national parks as well, which are outside, but like you'll find that kids that grow up like I did in like a place outside of London called Basingstoke, we don't actually have that as much access to green space as the people like down the road who can just walk to Victoria Park. Like this absolutely huge thing that they can run around and roller skate and cycle in and all the rest of it. So just one of the things. But like there are lots of trees in cities. It's not just buildings, unless it's cyberpunk. But like cyberpunk is like so 2077. I think it's just over. So that was a really good joke as well. So sorry if you didn't get it. Anyway, so yeah, just remember to put the trees in. I know we're not allowed to talk about trees with PCG anymore, but remember to have enough greenery. That is the big tip for cities.
Yeah, absolutely. I suppose I can let the tree talk slide this once. No. Awesome. Well, I think that mostly wraps up the questions that we've gathered throughout. A lot of them you also just kind of answered naturally throughout your demo, so awesome job there. But I want to open the floor one last time to the both of you in case there's anything either of you feel like you want to say at the end here, anything that maybe wasn't included or you want to make sure people know about. Any last, ooh, I was about to say any last words, and that sounds like a threat. It's not supposed to be, but here we are.
Do you want to go first?
No, apart from like massive thanks to you for putting that together, like then no. Just thank you, I guess.
Okay, well, so same to you. Thanks for building the PCGX. Like we didn't get time to talk about it. There is lots of other procedural stuff you can do in Unreal. So look at meta sounds, look at the texture workflows, not textures, sorry, the materials that you can do. Meta sounds in particular, I'd just like to give a shout out to because you can do some really cool stuff with that, totally procedurally. Just like I've created some voices for the robots, for example, that are just sound kind of right for, well, what I think right for robots is. But they're just using meta sounds. And in meta sounds, you've got this whole synthesizer, a whole modular synthesizer just sitting there, really easy to use. So if you know anything about music at all, if you're interested in that side of things, or sound effects, like definitely check out meta sounds for more potential for this kind of like procedural generation. And the other thing I'd say is wishlist my game on Steam. It's called The Last Gig. Do it now before we forget. If anybody knows of like publishers who'd like to fund me to do this, that'd be really good to know as well. But yeah, that's kind of it for me.
Awesome. All right.
And thank you, Tina, for having us as well. I should say. I'm sorry the cat didn't actually get on the desk.
I
Uh,
know, I know. That's the one regret I have of this whole thing is we were promised cat at one point and then it never came, but that's all right. Yeah, thank you both so much for taking the time to be here today and to do this and to walk through these tools and how you've used them. It's a really, really great example of how stuff that has been made can be built upon and in some ways even improved and expanded. And again, this was all, I mean, Tim, it's free. It's open source. It's community driven. That's amazing. So thank you for doing this and setting up these tools and having them available to the public. And thank you, Ed, for walking through this really awesome demo that you did for us. It was very thorough, explained exactly the thought process of how to go through. And also thank you for that little section at the beginning for some of our developer friends here who might be new to PCG in general to learn about some of the tooling and some of the setup there. So can't thank you both enough. This was awesome. And then, of course, thank you everyone who came to watch the show. It wouldn't be what it is without you and your input and you being here and interacting and asking questions. If you came in at any point partway through the show, no worries, because we post all of our streams in video format that can be viewed on demand on both our Twitch and YouTube channel at Unreal Engine. You can also keep up with us at Unreal Engine on all of our socials to keep up with the latest news, updates, and all that kind of good stuff. And then last, but certainly not least, if you're not already, I highly recommend that you come join us on the Epic Developer Community. That's where we house pretty much everything to do with the engine. We have our forums there where you can meet other like-minded developers and get answers to questions that you have. Also on the forums, this was a recent change. We've started pulling over questions from our UDN or Epic Pro support services that you can also view on the forums as well. So you can see these verified answers directly from Epic staff, hopefully answering questions that you may have come across from your own projects as well. We also have lots of tutorials, both from Epic staff and the community as well, and pretty much anything you could need in regards to the engine, to Epic tools, documentation, all that kind of stuff. So go check that out if you haven't already. But with that, that's everything for today. One last big thank you to our incredible guests, and one last big thank you to you all for watching, and we'll see you next time. Bye, everybody.